Okay guys, these are the solutions for the first three questions of the potential paper. So question 1 part A, integral of 0 to 1 over 3 e to the 3x over 2 e to the 3x minus 1 dx. Let that equal to I, and also let u equals to 2 e to the 3x minus 1, so du dx is 6 e to the 3x. That means 1 over 6 du equals e to the 3x dx. And also I need to change the limit, so when x equals 0, 2 e to the 0 minus 1, which is basically 2 minus 1, which is 1, and when x equals 1/3, that becomes 2 e to the 1 minus 1, which is 2e minus 1. So the integral becomes 1/6 integral of 1 to 2e to the minus 2e minus 1, which is du over u, and then you integrate it and you get 1/6 ln u between 1 and 2e minus 1, and then this 1/6 ln 2e minus 1 minus 1/6 ln 1, which is equal to 1/6 ln 2e minus 1. And this integral is 0 to pi over 6 tan squared x dx equals to I. So I'm going to use the identity 1 plus tan squared equals x squared x, which is tan squared x equals x squared x minus 1. So if you substitute that, you can integrate quite easily, and as you see, you get the answer 2√3 minus pi over 6. Okay, so part C, 0 to pi over 3 cos squared x dx, let that equal to I. So I'm going to use the cos double angle formula with 2 cos squared x minus 1. So you can rearrange that to get half cos 2x plus half equals to cos squared x, and when you substitute that in, it becomes integral of 0 to pi over 3 half cos 2x plus half dx. And you integrate it, and then you get √3 over 8 plus pi over 6. Okay, so that's question 1. Now question 2, x is equal to 2 minus cot theta, y is equal to 1 minus cosec theta. So cot theta equals 2 minus x, and cosec theta equals to 1 minus y. So 1 plus cot squared theta equals to cosec squared theta. That's the identity, and if you just substitute that in, you can see it's 1 plus 2 minus x squared equals to 1 minus y squared. So square root of 1 plus 2 minus x squared equals 1 minus y, so y is equal to 1 minus square root of 1 plus 2 minus x squared. Okay, now for part B, x equals 2 minus cot theta, so dx d theta equals to cosec squared theta, dy d theta equals to cosec theta cot theta, and when you simplify it, you get dy dx equal to cos theta, and when theta equals to pi over 3, dy dx equal to cos pi over 3, which is half. Okay, now part C is working out the normal. So the gradient was half, so the normal gradient would be minus 2. So when theta equals pi over 3, x works out to be 2√3 minus 1 over √3, and y works out to be √3 minus 2 over √3. So you plug into the equation and you get this √3y plus 2√3x plus 3√3 plus 4 equals to 0 as your equation. Okay, so that leads us to the vector question, which is a very long vector question actually. So we've got the points A, B, C. So to get the equation of AB, I just worked out the vector AB, and then the equation is 1, 0, 3 plus lambda 2, 2 minus 4. I mean 2, 2 minus 4, you could use it as 1, 1 minus 2 as well, because it's a scalar factor of 1, 1 minus 2. Part B, similarly, AC equals to 1, 1 minus 3. So the equation is 1, 0, 3 plus mu times 1, 1 minus 3. And then we need to work out this angle. So I let A equals to the vector AB and B equals to vector AC, and then I got A dot B, A modulus, B modulus, and then cos BAC is equal to that. I get BAC equals to 10 degrees exactly. But it's 10.0, I rounded it. Okay, now these are a bit messy, these parts. So part D. So D lies on AC, and actually this is AC, so let me just write that down. So that's A. So you can see AC and AD are equidistant, so because D lies on AC, so we've got D written in terms of mu, and you work out vector AD and AB. So AD works out to be mu minus 3 mu, and you know the distances are the same, and then you get mu squared equals 24 root over 11, and then mu equals to root of 24 over 11, and then mu equals to this, which is 1 plus 2 root 6 over 11, 2 root 6 over 11, 3 minus 6 root 6 over 11. And then for the final part, well, part E, so B is that, D is that, so BD would be D minus B, which is that, and then BD modulus is 0.733. Now to get question F, so the point E lies on AB such that CE is the shortest distance from C to AB. So you work out point, so point E is on AC, so it will be 1 plus 2 lambda. So the point E is on AB, so it has coordinates 1 plus 2 lambda, 2 lambda, 3 minus 4 lambda. And you know the dot product is 0 here because it's perpendicular. So what I did is I worked out AE and EC, and then I did the dot product here, which is equal to 0, and then I get lambda equals to 3 over 4 or 0, and then you plug that in. Obviously lambda can't be 0. Well, it can be, but then obviously it becomes just the point A. So what I did is I used 3 over 4, and I get my point to be 5 over 2, 3 over 2, 0. Okay. Okay, so I will be posting the questions 4 to 7 on the next video, guys. Good luck.